Hi guys, this is Joshua from Motivao Online Instructors. Today we're going to talk about the 1998 Harvard MIT Math Tournament for question number 6 of the calculus part. It states, Edward, the author of this test, had to escape from prison to work in the grading room today. He stopped to rest at a place 1,875 feet from the prison and was spotted by a guard with a crossbow. The guard fired an arrow with an initial velocity of 100 feet per second. At the same time, Edward started running away with an acceleration of 1 feet per second squared. Assuming that air resistance causes the arrow to decelerate at 1 feet per second squared, and it does hit Edward, how fast was the arrow moving at the moment of impact in feet per second? Okay. So notice for this exercise that we need two equations. We need the equation for the arrow and the equation for Edward. So let's start with Edward's equations. The acceleration of Edward with respect to time is just 1 feet per second. It's a constant, right? Per second squared. Now, if you know from calculus and physics, the derivative of the velocity is the acceleration. So to find the velocity, we need to integrate the acceleration. So the velocity with respect to time is equal to the integral of a of t dt, which is in this case is just 1 dt, which is just t plus a constant. Now to find that constant, we need initial conditions. The initial velocity of Edward is 0, right? Because he started running from 18,000 feet, 1,800 feet. So it's v of 0, which is c, is just 0. So this implies that the equation for the velocity of Edward is just t. Now to find the position of Edward, again we need to integrate, because the velocity is the derivative of the position. So we integrate the velocity of Edward, which is just the integral of t dt, which is just t squared over 2 plus c. Now again, to find c, we need an initial condition. And the initial position is 1,875 feet. So let's plug in that. feet. This implies that the position of Edward is t squared plus over 2 plus 1,875. Now let's find the arrow's position. By the same concept, the acceleration of the arrow is a constant, which is minus 1 feet per second cubed, second squared. Now the velocity of the arrow is the integral of that. So it's minus t plus a constant. Now the initial condition for the arrow, for the velocity of the arrow, is 100 feet per second. So in terms, the velocity of the arrow is minus t plus 100. Now to find the position of the arrow, we need to integrate the velocity. Which is just the integral of minus t plus 100 dt, which is minus t squared over 2 plus 100 t plus a constant. The initial value for the position of the arrow is 0. So we plug in, and we have that the position of the arrow is minus t squared over 2 plus 100t plus 0. Now, in the time that the arrow impacts Edward, it's when they both meet at the same position. So we have to equate those two equations. So we have that at the moment of impact, x of a of t is equal to x of e of t. So let's equate those two equations. Equal, well, what is the position of Edward? It's t squared over 2 plus 1875. Now, once we equate those two equations, we have 0 equals t over 2, t squared over 2 plus t squared over 2 minus 100t plus 1875, which is just t squared minus 100t plus 1875, which factorize in t minus 25 and t minus 75. Now, those two values are mathematically correct, but realize that if we only have to choose when t equals 25, because once the arrow hits Edward and it's a fatal attack, then he's not going to get up again, right? So t equals 25 is our impact time. But we want the velocity of when the time equals 25. So let's plug in t for 25 in each one of them. It doesn't matter which one. So the velocity of the moment of the impact equals minus 25 plus 100 equals 75 feet per second. And that is our answer. Thanks again, guys, for watching. Please subscribe us at motivao.com. You can check our website. You can check our Facebook. Just let me know if you have any other questions. Thanks again.